We'll begin our study of calculus with a quick pre-calculus review. So this will be somewhat brief. There, you do have a textbook. You can go through there to fill in some of the gaps. We're going to hit the highlights here. I'm going to start with the definition of a function because that's what we deal with in calculus, is we deal with functions. And so here's the definition. It says a function is a rule, or you can say formula, or just something that assigns each number x, and x is arbitrary. It doesn't have to be x. You can use whatever letter you want for this, but we're going to be dealing in this class mostly with x's from the x-axis. And that rule or formula is going to assign those x's to exactly one y in the from the y-axis, and then we'll talk a little bit about this notation here, just as a reminder on what that means. And so let's take, for example, y equal x squared. So there's a formula. And so I've got these x's that I'm going to be plugging in. I'm going to use this formula to generate some y's. And so you can plug in whatever you like. -1, you don't have to put in nice values. You can put in fractions or radicals or whatever. And so I can plug in any kind of x, and what I'm looking at is what the outputs are from these particular inputs of x. And what I'm doing is squaring, and I'll get my y here to be 1 from this formula. And then I plug in 0, I square that, I get 0, I square a half, I get fourth. And so I just keep going along, but I can see on this one that when I square it, I get 1. And so it's also going to that number as an output. And so the question is, does this violate the definition that I just showed you on what a function is? Does that rule or that formula assign each x to exactly one number y? Well, let's go see. This x, the only one that might be a problem is here, because I got two of them going to the same y, but this x is going to exactly one y. This x is going to exactly one y. It just happens to be the same y that this one went to. I would have a problem if somehow this x went to two y values. That we would no longer call a function. Doesn't mean it can't happen. There are places in this class where we're going to have things do that, where one input value gives me two output values. But that is not something we call a function. Functions satisfy that definition I was just showing you, and this doesn't happen in this case for this formula. We don't get two different values, and we know that no matter what I plug in, when I square something, I don't get two different outputs. Any number you square, you get the square of that number, which is predetermined. There's not two outputs for that. So this is a function, and these input values, these x's that we're plugging in, those are what we call the domain of the function. That's the definition on this other page here. The domain are the input values, and that's all the x's for which that function is a real number. For that is the output. Remember, the f of x is going to represent my output up here. The range, those are the output values, and that's all the possible y's that I can obtain from whatever that formula is doing. And so in this case, that's what I've got. I've got these input values, and these aren't the only ones that I can use, but the input values are my domain. And then over here, whatever comes out, those are the ones that we call the range, and those are the output values. Well, for this one, the domain, which we normally just put a big D for domain, the domain for this function, so I have to look, are there any x's that I'm not allowed to square? In other words, is there anything that's going to generate a number that's not real when I plug it in? And there's not. No matter what you plug in, so the entire x-axis is the domain. So looking at the interval for which this makes sense, these x's, all of them make sense to be plugged in. So I don't have to restrict it at all. The range, this is now a little bit tougher problem because it's asking me what happens after you plug numbers in. What am I going to get out? Well, this one's not too bad here because I'm squaring, and I know that when you square a number, you'll never get a negative number if you square a real number. So I know I'm not going to get anything negative. So if I'm looking at my y-axis, I know that I can get 0 if I plug in 0, and all I'll get is positive numbers. So numbers this way. So my y values that I'll get, I can get 0. I use a bracket to include it. Notice parentheses because you can't ever include infinity. And I can get as big a number as you like. You can square numbers and get huge numbers out of this. So it's just a snapshot of what can be plugged in and then what you'll get out. That's what the domain and range are. So it just tells you what values are involved. And then we use this notation, f of x equal x squared. That's the way you read this, is f of x. That's our function notation. If you don't like it, you can always just turn it back into y, but we use this notation because it's a little more convenient when we do things. For example, I can simply say, what is f of 3? Well, that means it's like a fill in the blank. Wherever the x is, that's where the 3 goes. So I just fill in the blank, and this is the same. Whatever you plug in, you're going to square it. I'm plugging in 3, I square it. And so there's my input value, that's my x. And there's my output value, that's my y. And it's nice and convenient because x's and y's, we think of those as being an ordered pair, a set of coordinates. And that's what they are. These are a set of coordinates that I can then plot. Go over here to 3, go up here to 9, and plot that point. That's on the graph of this function. So all the coordinates that I can generate by plugging in x's and getting y's give me a graph. And in this particular example, the graph I end up getting is what we call a parabola, and we'll look at this a little more in another video, but we get a parabola. And you can see the domain, these are the x coordinates. All of the places where I have the graph defined, those x's are included in the graph. That's the domain. And notice the range starts here. That is, the y coordinates start there. And the only y's involved, I don't have any y's down below the axis here, below the x-axis. It's only from 0 above. So that's our function notation. We use it for other things in here. For example, I might ask you to evaluate that function at t squared minus 1. Well, you interpret that to say, whatever you plug in, you're going to square. So I'm going to square t squared minus 1. Don't make the mistake of saying t squared minus 1 on the outside. I mean, this is going to get plugged into, and whatever you're doing to the x, you're doing now to this t squared minus 1. And you can actually multiply it out or whatever else, but just get familiar with the function notation because we'll be using it regularly. And so just a few more places of talking about domain and range. Suppose I have the function 1 over x minus 1. This is a function. Turns out that as long as I've got my y solved for, and that's what the f of x is taking place of, as long as this only involves combinations of x and using our normal basic operations of addition, subtraction, square roots, powers, even trig functions and so forth, as long as I don't have another y mixed in over here, then it's going to be a function and there's no weird symbols or whatever going on. But for the most part, as long as I have a nice formula with y on this side and all the x's on this side, it's going to be a function. If there's a plus or minus showing up or some other things like that, then you do have to worry about whether it's a function anymore. But almost everything we write down will be a function, but not everything. And we'll point those out when we get to them. But this is a function, and its domain, well, I want to get real numbers. Well, this thing's not defined if I get a 0 in the denominator, and that's going to happen if x is 1. So one way to say this is I don't want x to be 1 as an interval, which is normally how we display a domain. I do it this way. I say go from minus infinity on my x-axis all the way to 1, but don't include 1. Then I need to get to the other side, right? This is the one I want to leave out. So I'm taking all these, I'm leaving out that, and now I want to take all these. So now you start back up. We use the union symbol, which is, you can read it as an or you can go past 1, but don't include it, and then go to infinity. So it's kind of a clever way to skip over 1. The range is a little tougher here because, again, you're trying to see what happens after you plug in a bunch of x's. And so what I'll do in this case is I can see that I can't get 0 because this is a fraction. And the only way for a fraction to be 0 is for the numerator to be 0, and that numerator will never be 0. So I can see that the y coordinates for this particular example, I can never get 0. What else? Can I get positives? Sure, I can get positives by plugging in x is bigger than 1. The top and bottom will both be positive. And I can make this x bigger, closer to, as big as I want to make this fraction small. Or I can get as close to 1 as you want to make this denominator small, which makes the fraction big. So what I'm getting at is I can get small positives or I can get big positives. So, and I can do a similar thing with the negatives. Just be sure you're putting in numbers less than 1. So the only thing I'm going to miss is 0. So it turns out the way I would write that is go up to 0, skip over it, and then start back up and go to infinity. So the general rule is you got to eliminate anything that gives you a 0 in the denominator. That's for the domain. For the range, it's not obvious. That can be more work, and it may not be easy to find. But we're looking at some here that aren't too weird. Let's do one more. Suppose let's use different notation, different variables, so we're not imagining that we're stuck with just certain variables. So suppose I've written my function as t, a function of t this time, g of t. The domain for this is a function, by the way, because it all involves my basic square root and addition. The domain for this, well, this time for it to be real, I have to have this be true. I've got to have this radicand be bigger than or equal 0, which means I have to have t then bigger than or equal -1. So the interval on the x-axis, in this case the t-axis, I start at -1 and I take all of these. So I start at -1 to infinity. And then the range, this one I can do because it's a square root, and I know that square roots are positive. They'll never be negative. It can be 0. If I put in -1, you can see I can get 0 by plugging in -1. And then I can get this as big as you like by putting in as big a t as you want. So I can get as big a number as you want. And that's all it's saying. So just a snapshot of what can be plugged in, what will come out. So that's our basic function notation. We'll be using functions throughout this course.